next up is what we call the first derivative test. We're going to use the first derivative to figure out what a graph should look like, where its inflection points are, which we'll talk about later on, and where the critical points are, and how they are going to be either a minimum or a maximum depending upon what's going on with the rest of the graph. Now, I would also suggest using your calculator to graph these equations so that you can see how these are playing out. It would probably help a lot. Now, I won't be doing that because I'm already visualizing in my head, but I think it's a good idea for you to do that. So when we get to a problem, pause it, put it into your calculator, put it on Zoom Standard, and then manipulate the windows so you can get a good idea what the graph looks like. Okay? So, first derivative test is about decreasing and increasing functions. So part of the graph is increasing where the slopes are positive, and when decreasing the slopes are negative. Okay? Now, so we're going to be looking at the slope values, and the slope values being positive means it's increasing, slope values being negative or decreasing. And if it equals 0, then it's going to be the same all the way across the interval that you're looking at. Now, intervals are a big thing in this one, and you'll see what I mean when we get to that point. Now, there's certain guidelines that we're going to follow. Now, this is a lot of blah, 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 but basic idea is that you need to find the critical numbers first in the interval AB. And we simply do that by one of two things, either finding the value of the slope being equal to 0, or the value where it's not existing because the denominator is 0. The numbers that allow those two conditions to happen will be the critical numbers, and then we'll find the critical points based upon that. Okay? So, then we have to determine the sign of the function. If it's a positive value, it's going to be increasing, and it's a negative value, it's going to be decreasing. And then we're going to represent the intervals that we're going to be doing tests on. And what I mean by that is we're going to pick a point in a certain interval to see if we get a positive or negative value to determine if it's increasing or decreasing. And we represent it like this. And of course the parentheses means it's open. And we can go as low as negative infinity because we're not going to have specifically designed intervals like from -1 to 2 like we did in the last assignment. We're going to be going all the way to infinity in virtually all situations depending on what's required. So these are examples of what it will look like when we'll have numbers instead of letters A and B. And you'll see what I mean. It doesn't mean a whole lot now, but it will when we get through the problems. So the first derivative test is going to tell us if we're going from a negative to a positive at C, and that means that the function has a relative minimum at the critical point based upon the critical number and the value of y for that critical number. If that slope changes from positive to negative, then the f has a relative max. In other words, if it's going up and then coming back down, the point at the top, like a roller coaster, that's the highest point. So that's a relative maximum. And if it's positive both sides or negative both sides, then that means that there's going to be neither a relative minimum or relative maximum related to those two. Again, I understand it doesn't mean a whole lot. It will when we do the practice problems for your practice problems. So let's take a look. Well, here's what a diagram looks like. It's going up, so we got a slope right here that is supposed to be tangent. The slope is positive, so that means it's increasing. The slope here is negative, it's decreasing. As you go from positive to negative, this is a critical point right here. Because it's going from positive, then changing to negative. This is the relative maximum. This is going down here and then going up here. So that means it's going to be a relative minimum here. And these are two critical points on that curve. And of course, going from, because that's going down to negative, this is going up to positive. So that's what we're looking at here. But we're going to do this from an algebra point of view and not a graphic point of view. And this is why I suggest that you plot the graphs using y equals on your calculator and appropriately figure out what the window's going to be for your best view of what's happening. So we'll start with this. This is the function, and what we need to do is to find the value of the derivative or the slope. at any point on that curve. So this becomes 2x, that becomes minus 6. Now for the critical point, or critical number, for x, or c, then this is going to be f of c equals 2 times c minus 6 equals 0. And as you see, you add 6 and divide by 2, c is going to equal to 3. So that is the only critical point number that you have. Now, the critical point, then, you go back to this right here, and this is your x. Now, this is f of c, is going to be equal to 3 squared minus 6 times 3, which is going to be negative 18. So that means the critical point is going to be 3, sorry, that's not negative 18, it's negative 9. Negative 9. Negative 9. Okay? So we're going to see a change at the point through negative 9. So we need to look at the intervals. We got two intervals here, from negative infinity to 3, and then from 3 to positive infinity. And we need to see if it's increasing or decreasing during those intervals. So for the first interval, I'll call that I sub 1, is going to be from negative infinity to 3. So I'm going to test with a number between negative infinity and 3. I'm going to test with a 2 here. So I'll test 2. So I'm going to plug it into my slope. The slope now goes right here to see what the slope looks like. Okay, so this becomes 2 times 2, because we're testing 2 here. Then minus 6. And that gives us negative 2. And that tells us, the fact that it's negative, that it is decreasing in that interval. It's going down. Okay, so interval 2 is going to be from 3 to positive infinity. So I'm going to use 4 to test it. So that means it's going to be 2 times 4 minus 6. Oops, wrong place for the parentheses. 2 times 4 minus 6 is positive 2, and that means it's increasing. So the critical point 3, negative 9 fits right here between the two. And since it's decreasing, it's going down, and then it's increasing. That means the point right there is your critical point, which we said is 3, negative 9. And that is going to be your relative minimum. Okay? All right. That's how you do number 17. We'll jump now to number 23, which I erased the problem for, so let me put up there. F of x equals x squared times 3 minus x, and I rewrite that to be 3x squared minus x cubed. So the first thing I need to do is find the equation for the slopes for all points. So f prime of x is going to be 3 times 2 is 6, x to the first power, which is just x, minus, and then 3 times 1 is 3, and then x squared. Now, to find the critical numbers, whatever it is, we set this equals 0. 3x minus 3x squared equals 0. I'm going to factor that out. We factor 3x out, so 3x times 2 minus x equals 0. So that means 3x equals 0, and 2 minus x equals 0. And when that happens, the critical numbers become 0 here, and we subtract 2, and then multiply by negative 1, and we get 2 for the other critical number. Okay? So the critical points that we're going to have here, we go back to this first equation right here and replace 0 for both of those. So 3 times 0 squared minus 0 to the third power is 0. So the first critical point is going to be x is 0 and y is 0. And then the second critical point is going to be for 2. So 3 times 2 squared minus 2 to the third power. Well, that's 12 minus 8 is 4. So the other critical point is going to be 2, 4. Okay, so the fact that we have these two critical points means we have 3 intervals, going from negative infinity to 0, then from 0 to 2, and then from 2 to positive infinity. So this is going to be, I'll start with I1, and this is going to be from negative infinity to 0. I'm going to use -1 for my test here. Test, which we all know begins with the letter F. For some of you, that may be true. Test with -1. I'll just write it out. Test -1. Okay. So now we go to the slope formula that we got there. So 6 times -1 minus 3 times -1 squared. And that gives me, looks like -9. Okay? So, that means it's negative. Therefore, this is decreasing. The second interval is going to go from 0 to 2. So I'm going to pick 1 to test this. So this becomes 6 times 1 minus 3 times 1 squared. 6 times 1 is 6, 3 times 1 squared is 3, 6 minus 3 is 3. That is positive, so that means this is increasing. Now, that first critical point, 0, 0, is going to be between these two right here. Now, since we're going from decreasing to increasing, that's going to make that a relative minimum. Okay, now the second critical point is going to be between these two intervals right here. So I3 is going to be from 2 to positive infinity. So your third interval is going to go all the way to infinity. And this, I'm going to test with 3 here. Test 3. So that's going to be 6 times 3 minus 3 times 3 squared. That's 18 minus 27. That's a -9. So that's decreasing. So now your curve is increasing, and then it's going to start decreasing. So the top of the roller coaster there is your relative maximum. And that's how you do 2 intervals, or 3 intervals for 2 critical points.